we will now talk about something that is very important for this industry, and I'm excited to dive in. We will talk about modular tool concepts, and I truly believe that that is the model we will use in the future. And we have a presentation that is called From Precision Bore Finishing to High Performance Face Milling, and I would like to welcome to the stage Director Engineering Tools of Urma AG. His name is Juri Vers. Hello. Quick comment on the discussion round. That was very exciting because that topic is a big problem for machine tool manufacturers. Mr. Engels says that we should simply get going, start doing something, analyze where you want to go, and then just get started, and then the solutions will come around. Right, let's get back from the virtual world, from the AI world to hardcore milling tools. We'll talk about modular tool concepts. Right, I don't want to go into too much detail on the company that I work for. Nothing, I don't think the presentation is working. Right, just a few details on my company. Innovation is our tool, that's our motto. So anything you will see in this presentation is tool concepts that you may have heard of in some way, but you may have not seen it like this. So let's start. I would love to see my slides, but I don't think they're working. What's the problem here? Can you please click and give me my slides? Okay. Right. We offer different products around drilling, turning, roller burnishing, deep rolling, but I would like to concentrate on reaming and honing and milling today. And I would like to go in reaming systems. That is what we've been doing for a long time. Modular systems is what we usually do. We have a tool here with a high-performance reaming head. We cover diameters of 7.6 to 200 millimeters, and we can use different metals, carbide, cermet, reaming insert for cutting. We have our custom developed PVD coatings in order to offer the highest comfort for working these, for using these with high process parameters, and in order to introduce you to a very simple way of reaming. That's what this looks like. 3 different systems, a very small system. That's the smallest patented modular reaming system in the world, up to 13 millimeters. Then there's the big system here with preset cuttings on the cutting ring. And I would like to concentrate on this one, the RX medium, for this presentation. It ranges from 11.9 to 140.6 millimeters in diameter. So a hard metal ring, one hard metal ring, you can apply it to this system. What's the special thing here? If you get a tool ready for use, you do that in the workshop. It is then put into your machine with pre-settings, and we do this in a different way. The tools are set directly on the spindle. We put them onto the reaming bearer and thereby compensating for concentricity errors in your spindle directly. So we offer very high precision of the cone. The diameter is less than 5 μ. If the cutter is then wear down, you change it. There's a high change accuracy. The change accuracy is very high if the position is similar to a hollow shank taper position. You can use this for compression and surface pressure. This is a modular system, and this doesn't only apply to the cutter, it applies to the bearer, to the spindle. We have different components for the reaming system to be adapted to your machine. This might look like this. Is a standard tool adapted to clients' need. So with these standard components, we can cover most of our clients' needs. We offer our own tools. So if you start using these tools, you will reach a limit in your application at some point. And a good way of solving that problem, if you know your application, you keep using your PVD finishings. This is a traditional PVD coating after 30 meters of production. If you know your application, you can increase your tool life by 100%. This is what we came up with. You can see that here on the right. Right, this also works for special tools, so more complicated applications, for example, relay reaming tools, where you can have two tools working on guide pads for hydraulics, for example, or tools with additional components. There are many, many great solutions in order to make our clients' life easier. Right, let's look at a typical application of this system. This is a rather long tool, 20 times the diameter, 42 chromo 4. So our client claims high precision. The cuttings need to be taken out of this process. We start with a VC of 125 meters per minute. And it is very easy to handle. This is a rather small tool, but this also works for large engines. This is very interesting today because many AI data centers they are not fueled by green electricity, but with engines like this. This is a special application, I know, but I wanted to show you that that doesn't simply only work for small applications, but for larger ones as well. 180 millimeters is the diameter here. There is many more applications. This is a part of a cast pump. What's interesting here is the picture of the right. There are these cuttings, and for precision length, this needs to be compensated for. If reaming is not enough, if you need more precision, if you need a specific surface and the client has claims for the optics of a surface, you can then turn to honing. This is a portfolio that we offer. It's very interesting. You can combine these, reaming and homing, in one process. You have very high precision for honing, combined with specific tool parts. And the special thing here is that for the machining with these tools, you don't need a honing machine. You can use these tools for your usual machine. You then save a specific tool, a specific person. And that saves a lot of time and money, and you can reach very high geometrical positional tolerances and surfaces. This honing is used for high accuracy machining. So we use abrasive material on honing stones, and usually you get the crosshatch pattern that we got for engines. That is what we reach here as well. I have another example here for you. This is a multiple step process. This is 3 months old. This is a rather recent example. This is a 5-step process, 25 millimeter drilling, 25.85 millimeter double cutter. Then we have the reaming, the pre-honing, and the finish honing. These are the main steps that I would like you to look at. That's the reaming tool. It looks like this. We have 162 length, RA 1.65. That's the result for this diameter. And if you pre-hone, then the diameter is increased 26.005. RA goes down, RZ goes down 2. This is the surface that you get, that V pattern, a beautiful surface. and this holds the lubricant a lot better as well. Here's a video, one tool machine. Usually this would be done by 2 machines. They're not cheap, so that's a big saving. Here's the process, the change of the tool, and then it keeps honing. This is real time. This video is not sped up. So the tool hones the workpiece, goes all the way through. That's the pre-honing process. And then we get the third tool for fine honing, the typical strokes that the hone machines do. And go. So that's where the V-shape, V pattern is created. So 1 micrometer in honing is cut into the surface here. With these concepts, you can also do other machining process. So what has milling to do with the reaming? Well, not so very much, but the game code of our tool is that at some was so well thought through at some point that we thought we could apply this to milling processes as well. This is a milling tool that I brought for you. I have it in my hand here. So this is a new system. We came up with a new concept, PKD or CBN, equipped hard metal milling machines. These are tools for very simple machining at the end of the day. It's a simple surface finishing tool. This is the cutting head. The cutter head, it is built in a modular way in order to save. It's super light. We have a cooling plate. The cooling is not pushed into the workpiece. It is distributed evenly on the top of this cutter head. This is a workpiece, and you don't want to clean that afterwards. So we can get rid of the cuttings in the process. This is a hard metal cutter head, and during the process you can decide what you actually need and then adapt the sizes. You get a very high axial positioning accuracy, very high precision, and in order to give you some context, this is a comparison of a standard cutter head system. I took a random one from the internet so that you don't immediately know who built this, and this is ours, and you can see these cassettes. And if you have a tool with 24 of these cassettes, you'd usually have to adjust each and every one of them. For this, you don't. This is work bias to less than 2 micrometers, and this saves a lot of time. It's very simple. You attach the cutter head to your machine. It is then adjusted axially. Then you attach the cutters and then the distributing plate, and then you can go. In order to show you what this looks like in the real world, at a university we made some tests. These are high-speed images on the left. This is the cutter head that I have in my hand here, and so the tool is on the left. The tool is vibrating, and on the right, this is a high-value cutter system, a traditional one, but you can see that there's a lot more cuttings. It is not very stable. You have the surfaces of less quality. The overall cutting process is not This can also be used with working pieces. You can see them here. A Swiss coffee machine manufacturer, and they use this cutter tool in order to produce these coffee cup machines. Here you can see that this is a very fast process, and the RP is at 4 millimeters. That's high quality surface working, and it takes little time. Right, the benefits here is that you get great surfaces, RA of less than 0.3 micrometers, RZ of 2.0 micrometers. And what we also realized, and that was decisive for the study that we then conducted, that you can see here in the middle is the first workpiece that we worked with, a prototype in Switzerland. What's so important here is that the workpiece was attached to the machine in a very unstable way. It was attached to tiny cylinders in the machine. It was not very stable. It was moving, and then there were major differences in the thickness of the walls. At the thinnest place it was 4 millimeters, and this had to be worked precisely with a precision of less than 4 micrometers. And clients before did that with a one cutting tool and it took 48 minutes. So we took our tool, and in the first test, the process time, we reduced that to 45 seconds, and we got the precision surface and the working in one process. And we ourselves were surprised how well that went. And we put very little axial pressure on the workpiece as well. And what we also realized is that we have a very low tendency for burr formation. And we tested that. We went into more detail on that. It's very, very interesting for component series manufacturing. You get these burrs at the end, and you need to machine them. I am very good with time. I would like to give you a summary now. I showed you some modular tools. Modular tools come with disadvantages, but they come with a lot of advantages. First, they save resources. So most of the components that I have in my hand here can be used for a very long time. The only thing that you need to replace is, of course, the cutting part, and that also can be repaired. You have a strongly lower setup and non-productive times. You attach the tool one time to your machine, and then you can exchange the tools. You don't have to stop the machine in between. That saves a lot of time. It optimizes your tool costs, because with higher process parameters you can do a lot more, and it saves a lot of tooling time. The handling is super easy, and you have a highest precision at the lowest effort in times where you don't maybe have that much resources available in your company. So you can increase your productivity and reduce the overall unit costs. And then if you look at sustainability, and I think that's a very exciting topic. Everybody talks about CO2 footprints and so on. If you have scrap, you are not sustainable, and it doesn't matter whether your electricity is green. You have scrap, you're not sustainable. So make sure that with your tools from your first cut, you do not have a lot of scrap or any scrap, and then it will still be worth it to get your electricity from a power plant and not from your own roof. I would like to thank you for your attention. If you have any questions, go ask them. Now, my colleague Gianluca does great application videos. He explains the tools. Gianni's Tooling Time on YouTube. He has this very, very nice way of explaining our tools, so please go and see that. Thank you very much, Mr. Vers. Give him a big hand. You now have the opportunity to ask your questions. I do have some questions on Slido, and I have some questions too. Now, let's look at the industries. What are the major applications for your tools? Where do your tools make the most sense? Well, yes, these reaming tools, of course, are tools for series production. If you want to produce a batch size of 5, this won't be of major use for you. But for the series production, access components, powertrain components, and so on. In workshops with shift workers for lots of tool changes, that's where this makes sense. We heard this in your presentation. Let's talk about service and lifecycle management. What's the impact here with your tools? Well, the components that you buy from us, sometimes that's investment components. You will keep these for a long time. They come with a high tool life. Sometimes they've been working for 40 years, and that's when they have to be exchanged. The cutting part, the milling part, or the honing part, we manufacture that with high precision so that you can use it for a long time. So you get perfect tools from us that have a long life cycle for your application. Now let's talk about costs. Amortization time, is that long? Well, these are not tools that you can get in any shop for private people. These are high-precision tools. They are manufactured in Switzerland. Switzerland is not known for being super cheap. Quality is at the forefront with us, which is why we have only expert, highly automated production. So we manufacture quality tools, high-quality tools. So in the long run, this might be a cheaper tool, but only in the long run. This is a cheaper tool than one that you might get in any shop out there. These tools are expensive. Often people don't want to spend that money. We hear that very often, but then if we tell them about the details and we ask them how often they need to change their traditional tools that they've been using so far, they find out, oh, that might actually be worth it. Amazing. Thank you very much. That was it. Thank you very much. Give him a big hand.